Whoa, this is intense. Magnitude 7.8 along the Pacific Ring of Fire, and that comes just shortly after we had some other two magnitude 7 plus, magnitude 7.6 and magnitude 7.3. And now magnitude 7.8 has just struck Indonesia, right in the Maluku region, one of the most complex tectonic zones on Earth. What is going on with the Pacific Ring of Fire or the Pacific Plate? Is this a ripple effect from the other quakes because the plate is being moved? So here is what should catch your attention, guys. One of the most complex tectonic zones on Earth, and magnitude 7.8, that comes just days after two other major earthquakes. Tonga, Vanuatu, three powerful earthquakes, different locations, but same systems. So what's happening beneath the Pacific Ocean right now? Let's break this down in a way so that it makes actually sense. So this Indonesia quake, let's talk about this first. It's not a normal plate boundary. You see it on the map. It's like a little bit of like an enclosed valley. This is one of the only places on Earth where a tectonic plate is being destroyed from both sides at the same time. You have something that is called double subduction. So as if one subduction zone is not dangerous enough, double subduction from both sides, you get the pressure. The subduction zones are the most dangerous earthquake and volcanic zones in the world, and the Pacific Ring of Fire, that horseshoe formed ring of fire that encloses the Pacific, we see the mega thrust earthquakes, the mega tsunamis. So magnitude 7.8 for sure can create a tsunami, but it's dependent on different factors. So let's have a look. The Molucca Sea plate, that's where we have this magnitude 7.8, is being crushed, squeezed, and forced downwards from both directions. That's how it's bent. So that creates stress from multiple angles, as you can imagine. It's not just one clean fault. So when that one finally releases, it releases big. That's how you get a magnitude 7.8. USGS has now downgraded it to 7.4. So, but now compare this to Tonga and Vanuatu. Those are different, but they're still connected, and I'll tell you why. Out there with the other two, you're dealing with like a more classic setup, so to speak, a classic subduction zone dangerous setup. The Pacific plate is diving beneath the Indo-Australian plate along deep ocean trenches. This is pure subduction. And when I released my last video about these two earthquakes, some of you said, well, I'm in New Zealand, I haven't heard about this. Press says nothing. Very surprising if you look at the location, right? So again, I said this is the fastest subduction on Earth. It subducts faster than in other spots. So in Tonga, especially, the Pacific plate is plunging down extremely steep, not at an angle, it's extremely deep and extremely fast. So that's why this region produces very deep earthquakes, very powerful earthquakes, and serious tsunami potential. Vanuatu sits along the same system, just further along this arc. So here's the key difference between the three. We have Tonga and Vanuatu, clean, fast, powerful subduction. Maluku in Indonesia, chaotic collision, double subduction, multi-directional stress, different mechanics, but part of the same larger system. Now let's zoom out a little bit. All of this sits along the Pacific Ring of Fire, and at the center of it all is one thing, the Pacific plate. And that plate is massive. It's moving, and right now it's diving under Tonga. It's interacting with Vanuatu, and it is transferring stress in fragmented zones of Indonesia. So think of it like pressure moving through a system. So when one section shifts, it can redistribute stress along the edges. It's not like dominoes in a straight line, but basically what we're seeing here, tension is moving through a cracked surface. So, and that's what makes this moment different, because we're seeing Tonga move, Vanuatu move, and now Indonesia releases a magnitude 7.8. That tells us one thing: the Pacific Plate system is highly active right now. Now, does that mean this is a foreshock? Now, does that mean a bigger quake is coming? No one can say that. We just can't say that, guys. But what we can say is this: this is not quiet behavior. I'm sitting along the Pacific Ring of Fire. I'm sitting along the dangerous Cascadia subduction zone that can produce a magnitude 9+. We're all doomed on the West Coast if that happened. We're dealing here with a stressed, moving system that is releasing energy across multiple major boundaries right now. And when you see activity like this spread across tectonic styles like this, you have to pay attention, and we are. So there's one more thing. This Indonesia quake didn't just happen on land. It happened in a region that is surrounded by deep ocean, steep underwater slopes, and active volcanic arcs. So that means the tsunami risk is real, aftershocks could be strong, and nearby volcanic systems are sitting on top of the same unstable ground. So we could see some volcanic eruption. Indonesia has so many active volcanoes. We've seen this with the Kamchatka megathrust earthquake, 8.8, that happened last year. We saw volcanoes erupt. So 3 major earthquakes in such a short period of time, 3 different tectonic settings, 1 connected system. The Pacific Plate is not quiet right now. It's moving, and when it moves like this, the effects unfortunately do not stay in one place. So I know the questions arise now. Can this trigger earthquakes on the West Coast, on the opposite side of the Pacific Plate? Can it trigger something in Japan, Kamchatka again, Alaska? Well, yeah, we could see some shaking, but not in the same way Indonesia moved right now. Not in the same way that we say, oh, California's next, right? The honest answer is a quake like this can sometimes dynamically trigger earthquakes very far away because seismic waves are traveling through the planet. And of course, then they can disturb faults that are especially close to failure, if they're already very, very close to failure, right? The USGS says that this kind of distant triggering does happen, especially in places that are already very active. So, but that does not mean, guys, that this Indonesia quake is now directly loading the faults off of the coast of the US or Canada or Alaska or Japan in some like clean domino pattern, right? The farther away you get, the weaker the direct stress on the other fault systems becomes, and most large distant quakes still do not lead to a major follow-on event somewhere else. What it really means that already stressed regions can sometimes get a nudge. So Japan, this is the one I would watch most closely right now in a broad ring of fire sense, because Japan is already one of the most seismically active plate boundary systems on Earth, with major subduction zones and also frequent large earthquakes. We see it all the time, right? That does not mean that a quake is heading towards Japan. If we look at the whole Pacific Ring of Fire and the earthquakes that happen there every day, this thing shakes every day. So you cannot say because it was shaking here, this is why it's shaking here. It's constant, right? But Japan is exactly the place where distant dynamic triggering is at least physically plausible, because the system is already under constant tectonic strain. And it's the same basic idea for Alaska. Lots of earthquakes in Alaska, right? Alaska sits on another major active subduction boundary there, so it's always capable of large earthquakes on its own tectonics. So a distant giant quake can pass seismic energy through the region, but whether that actually triggers anything meaningful really depends on whether the faults are already near failure. And what about the US Canadian West Coast? Possible in theory, I would say, but I would be really very careful with the wording. We have California with the San Andreas Fault. We have the Cascadia subduction zone. They're active for their own reasons. Yet saying this Indonesia quake means the West Coast is now likely to shake would be absolutely overstating it. The stronger claim is only that big earthquakes can send waves globally, and sometimes those waves trigger small or occasional distant events in vulnerable places, right? So could this be felt across the Pacific tectonic system? Yes, in the sense that seismic energy can disturb already stressed regions, but no scientist can honestly say this quake means the US West Coast, Alaska, or Japan is now next. And one more important distinction I have to say, if you're talking about tsunami effects, that is different from earthquake triggering, right? Tsunami energy can cross the Pacific and it maintains, and we follow the travel times for that. But tsunami arrival does not mean those distances are being tectonically loaded into a new earthquake. We also have a 5.5 aftershock already right now, so we will have to wait and see what is coming in. Actually, while I just said it, another one. So we have 5.4, 5.5 as aftershocks there already. The depth of the 7.8 earthquakes is 35 kilometers. That's roughly 22 miles. So 22 miles deep, that puts it in the shallow earthquake territory, and that changes a lot in how we think it could have done damages, right? Shallow earthquakes are the ones that do the most damage because the energy doesn't have time to dissipate. It hits the surface hard. Now think about where this earthquake happened. This wasn't deep underneath the mantle. This rupture happened relatively close to the surface in a region filled with a lot of islands, coastlines, and nearby populations. That means probably strong ground shaking across nearby islands, potential structural damage, landslides in steep terrain. And if it's shallow, we do have a tsunami risk. We need to know if there was a vertical movement on the seafloor. If there was a vertical movement, even just a few feet, that's enough to displace water, right? This region is perfect for it. Deep surrounding seas, steep underwater slopes, confirmed basins, bathtub effect, right? That's how you generate their localized but dangerous tsunami, not necessarily ocean-wide in this area. So there's no danger for the US West Coast and Canada, I think, from this one. But it's very real for nearby coastlines. So this earthquake wasn't just big. It was big and shallow in one of the most unstable tectonic zones on Earth. And this is where real impact happens, right? So I'll stay on the pulse of this for you guys. If you liked it, leave this video a like and a hype, share it with your friends. If you want to support the channel, click the join button or support it with coffee. I've already had a lot today because so much is happening. And hey, check out the video here in the end screen. You should really see that. See you there in a second. Stay safe, guys. Bye-bye.